So we are going to start here now. Higher order homogeneous partial differential equation. Higher order homogeneous partial differential equation. How to solve this higher order partial differential equation? The method is exactly similar to the higher order linear differential equation. So when we solve higher order LDE, we write its auxiliary equation. From the auxiliary equation, we get a CF, and depending on RHS, we get a PI. Then CF plus PI is our complete solution or more general solution. So exactly similar method is there in higher order homogeneous higher order, that is the partial differential equation also. So the differential equation, the higher order differential equation will be in this form. The form of the differential equation is like this, where now we use a capital D operator. Capital D operator, it is not for d by dx, we use dou by dou x. So partial with x, that operator is denoted by d, while d dash, we are going to use d dash operator by dou y. Dou by dou y. So whenever we use d by dou x and d dash by dou y, the differential equation is converted in this form. The form is phi of d comma d dash of z is equal to f of x1. Now the auxiliary equation will become phi of d comma d dash equal to 0, whose roots decides the complementary function. And depending on RHS, we are going to compute again a shortcut method, or we are going to see a shortcut methods for getting the PI particular integral. Today we will focus only on this first part known as complementary function. So the important thing is that we require the roots of this equation, and now to get the roots, we'll replace d is equal to m and d dash is equal to 1. So if we replace d by m and d dash by 1, we get auxiliary equation in terms of m, or we get algebraic equation of m, and we can solve that algebraic equation for m and we get the roots. And depending on root, we have a solution. So we'll come to that part in the next slide. Yes, so we'll observe the important thing. The important thing is phi of d comma d dash equal to 0. This is the auxiliary equation, and we are going to replace d by m and d dash by 1. Replace d is equal to m and d dash equal to 1. Suppose the roots are real and distinct, m1 and m2. Now see the change. When we have m1 and m2 are the roots in LD, we write its yc, the complementary function, as a c1 e raised to m1x plus c2 e raised to m2x. Means number of arbitrary constants c1 and c2 is equal to the order of differential equation that always happen there. And in PDE, in partial differential equation, we don't have the arbitrary constant, its position is taken by arbitrary function. So we say number of arbitrary functions is equal to the order of partial differential equation. So right now, if m1 and m2 are the root, we'll write its particular solution. Sorry, not particular solution. It's a complementary solution, that is f1 of y plus m1x plus f2 of y plus m2x. So it is a function of y plus mx. So suppose m is a root. If m is a root, f of y plus mx is a constant of complementary function. F is actually arbitrary function, is the constant now. So that way we are, or just remember arbitrary function will come there, not a arbitrary constant. So it will take f of y plus mx form. So if m1 and m2 are the root, we should write its complementary solution as f1 y plus m1x plus f2 y plus m2x. That is the first case. If m1 is a repeated, so we say f1 of y plus m1x plus x f2 of y plus m1x. So it is y plus m1x only, but the functions will be different, f1 and f2. Just like c1 plus c2x, we write c1 plus c2x. Here we write f1 plus x f2. f1 plus x f2. That is the way we deal with the repeated root. If it repeated thrice, we have f1 of y plus m1x plus x f2 of y plus m1x plus x square f3 y plus m1x. So we have to go on. In the same fashion. Which case is missing here? Daniel D. Yes. Which one is the case not written?
Complex roots.
Complex root, correct. So if we have the complex root, we don't have a new case here. Suppose we have a complex root alpha plus or minus I beta. What we are going to say, M1 is alpha plus I beta, and we'll say M2 is alpha minus I beta. Okay. If we have a complex root, say alpha plus or minus I beta, then just say the first root is M1 and second root is M2, and then this is only the solution. The solution will come Z equal to F1 of Y plus alpha plus I beta of X plus F2 of Y plus alpha minus I beta of X. Just M1 and M2. So same formula will be applicable for real as well as complex root. Real as well as a complex root. So that is the three different cases for getting the complementary function for the PDE. Okay. We'll see two examples and you'll get more idea about how to write the complementary function for the PDE here. Okay. So we'll come to the questions here. So question number 1 is here on the screen. You'll see solve d cube minus 3d square d dash plus 4d dash square of z equal to 0. Yes, you can start. I want the roots of auxiliary equation. Once anyone complete, you can tell me. Yes, anyone? Anyone got the roots? What should be done here? Step number 1. Yes, let. How to get auxiliary equation?
dm d dash 1.
Yes, correct. Let d is equal to m and d dash is equal to 1. So that you have to put it first. In the phi of d comma d dash equal to 0. Okay. Phi of d comma d dash equal to 0. We put d is equal to m and d dash is equal to 1. So if you replace d is equal to m and d dash is equal to 1, you will observe it is a m cube minus 3m square plus 4 equal to 0. This is our auxiliary equation. This is the algebraic equation in m. So find out the roots. Find out the roots of this cubic equation. We will get three roots there. So this is phi of d comma d dash of z equal to 0. Put d is equal to m and d dash is equal to 1 in phi of d comma d dash equal to 0. We get auxiliary equation or we get algebraic equation in terms of m. Roots of this algebraic equation will decide the uh, decide the ZC here complementary function. Yes, I think Sahitya got Z equal to or M equal to 4 as the root by hit and trial. Okay,
M equals to 2.
M equal to 2. Okay,
Yes,
good.
4.
Someone says 4, someone says 2. Okay, if you take 2, 2 cube is 8. 8 minus 12 plus 4. That is 2 is the correct one. I think 4. Okay. Yes, Iftikhar, yes, good. You got all three. Minus 1, 2, 2. Minus 1, 2, 2 are the roots. So there are multiple ways. First root you have to find out by hit and trial method. So 4 is a divisible by 1, 2 and 4. So you start with plus or minus 1. You will get minus 1 as a root. Or you can start plus or minus 2. You will get plus 2 as a root. Once you get one root, remaining two roots you can find out by actual division, synthetic division or grouping method. Number of choices are there. Choice is yours. I generally prefer synthetic division. I got minus 1 root here by hit and trial. So this coefficient written in decreasing order 1m cube minus 3m square plus 0m. Nothing is there means 0m plus c. That constant is 4. First coefficient taken as it is, cross multiplied and then added, and last term should be 0. So second quadratic equation, m square minus 4m plus 4, which become m minus 2 bracket square, and we get minus 1 comma 2 comma 2. These are the three roots of the auxiliary equation. Now if m is a root, we have f of y plus mx is a complementary function. Okay, so we have tried on that complementary function for each root. So case one is very simple. It is f of y minus x, because y plus mx, m value is minus 1. So f of y minus x is the first, or I would say f1 y minus x. But here it is repeated, so we'll say f2 of y plus 2x plus x f3 of y plus 2x. Okay, and that will be the answer. I show you the answer. The answer is at the bottom here. f1 y minus x plus f2 y plus 2x plus x f3 y plus 2x. That about a complementary solution. And here is no particular solution or particular integral for RHS, because RHS is a 0, so Pi is a 0. Pi is a 0, so only that ZC will be the complete solution. If anyone have any doubt, yes, you can ask here. No doubt. So can we? Are you completed? If you completed, tell me. We'll move to the one more question on this type.
Yes, sir.
Done? So again, a question is on the screen. So solve r plus s minus 6t equal to 0. R plus s minus 6t equal to 0. Do it. Yes, anyone? What is the differential equation first? Tell me. Tell me in a standard notation. Yes, anyone? What is the differential equation? No one is. What is the value of r? What is the value of r?
Del square z upon by del x square.
Very good. Okay, good, Neil. Okay, so it is a dou 2z by dou x square. Okay, dou 2z by dou x square, that is r. S is a dou 2z by dou x dou y, and minus 6, it is a dou 2z by dou y square. So r, s, t are the second order derivatives. So sometimes the question can come in this form also. Okay, already at the first session we seen these standard notations that can be used in PDE. So differential equation is this one. Dou 2z by dou x square. Okay, that is dou 2z by dou x square plus dou 2z by dou x dou y minus 6 times dou 2z by dou y square. And if we replace dou by dou x as a capital D and dou y as a d dash, okay, d and d dash. So the equation comes d square plus dd dash minus 6d dash square of z equal to 0. Now find out the roots. Find out the roots of auxiliary equation. Before that, you should replace d is equal to m and d dash by 1. D is equal to 1 m and d dash is equal to 1. Tell me the roots. Yes, everyone, what the rules? It's simple now. It's quadratic equation. You can easily find the roots. Okay, I got roots from I think Sahitya. Okay, let us check. Yes, Sahitya again. Minus 1 plus or minus 5 I by 2. Okay, okay, minus 1 plus or minus 5 by 2 only. Let me check. Let me check. What are the roots? No, not. Okay, so you not simplified. So it is 2 and minus 3, is that? 2 and
Yes, sir.
minus 2 and minus 3. So we'll put d equal to m d dash by 1. M square plus m minus 6 is the quadratic equation. M plus 3 m minus 2 are the factors. So 2 and minus 3 are the roots. So tell me the ZC then. What will be the complementary solution? What will be the what should be the complementary solution? Yes, anyone? Nobody is giving the answer. Huh? Obviously, F1 of.
f1 of y minus x2 plus f2 of y plus 3x.
No, 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 no. I think you are doing a mistake here. It is f1 of y plus 2x only, na? And f2 of y minus 3x. So you have to keep the sign as it is because it is f of y plus mx. F of y plus mx is the solution. Is that? So the answer is here f1 of y plus 2x. Okay, that's a nil. Okay, so this one is the answer. F1 of y plus 2x plus f2 of y minus 3x. And that about the complementary